Okay, hi everyone, I'm Kian. Today I'm going to explain example 9.2 for KM30903 Assignment 1.1. Example 9.2 Material effect on buckling load. The question given a column has a square turbulent cross section. The wall thickness is 10 mm and the column length is 12 m. The column is axially loaded in compressions and has pin ends. The mass of the turbulent column must not exceed 200 kg. It wants us to determine which metal in table 3.1 gives the highest buckling load. Also calculate the critical load. From the question given, the data we can get is the wall thickness with 0.01 meter, MA 200 kg, and the length of the column 12 meter. So first, let's assume that it's using Euro method. For Euro method, to find the critical load, this equation is used, and in these equations there are two unknowns that we have to find. The first unknown is the E, the elastic modulus, and the second unknown is the I, moment of inertia. For this E, we can directly refer in table 3.1 to get the value. Well, for I, first we have to look for the area for the square turbulence first. Also in the textbooks, we know that the largest buckling load would result from the largest value of E over rho. And we found that the textbook is using the magnesiums with E equals to 45 gigapascal and rho equal to 1740 kg per meter cubed as the method to solve this equation, By referring to table 3.1, I found that magnesium is not included in this table, and it's only magnesium alloys. Therefore, I add the magnesium into the table 3.1 to make the comparison with the other metals in table 3.1. So, what is the value of H? To find the value of H, first we have to look for the equations for the area. The equation for the area is equal to h power of 2 minus h minus 0.02 power of 2. So let this equation be equation 2. So the mass column is equal to rho times area times length. By substitute these equations into the area part, we can get these equations. Equation 3. So from equation 3, by put this rho L to the left hand side and simplify this part, we can get these equations. Therefore, by rearrange the h and the others value, we can know that the h is equal to MA over rho times length times 0.04 plus 0.01. Therefore, the value of h is being solved. For the critical load, first, we still need to find the moment of inertia. The moment of inertia for square turbulence is equal to h power 4 minus h minus 0.02 power 4 over 12. Okay, by express these equations, we can know that there is 1/2 of the equations is equal to this part of the equations. Therefore, we can replace that part of the equations into MA over rho L. Then we can get these equations. Let it be equation 5. Okay. So, that is typing error. By substitute the equations 5 into the equations 1, we can get a new equation for the critical load, which time power of 2 EMA over 12 rho L power of 3 times h power of 2 plus h minus 0.02 power of 2. Okay. So after I have key in the equation for H and for PCR into the Excel table, I have found that there is one more method which is high-speed steel with the highest ratio E over rho 0.026972, but the critical loss for this high-speed steel is much lesser than the magnesium. And here we can see that the magnesium with ratio 0.02562 have the highest critical loss among all the metals in table 3.1, which is 282835.3858 Newton. Okay. To make sure that I am not typing error in the using the Excels, I have calculated manually by handwritten on the table on the paper, and I found that the result is absolutely the same with the calculation in Excel. Therefore, I can prove that there is no calculation error in the Excel. Okay, to prove that Euro method is used for these calculations, we have to find and compare the value of cylinder ratio C and critical cylinder ratio CC. So for the C, we have to identify the value of LE and RG. So since it's both pins ends, we know that L is equal to LE equals to 12 meter, where for RG, where is equal to square root I over A. So for I, we just need to substitute the value of H with 0.249 into the equations, then we can get I is equal to 9.1172 times 10 power of negative 5. And for the area, also the same. Just substitute the value of H into these equations, then we can get 9.56 times 10 power of negative 3 meter cubed. Then we plug it in these equations, then we will get Rg is equal to 0.0977. Therefore, we can know that C is equal to 122.82. And for the CC, since there is no yield strength in the textbook for magnesium, I decided to use this formula to solve for CC. So by substitute all the value into the equations, I get CC equal to 122.523. By comparing these two, we know that C is larger than CC. Therefore, the Euro method is correct. For the conclusion, I found that the critical rate for high-speed steel with the highest value E over rho 0.026972 is only 14943.98 Newton, while the critical rate of magnesium with the second height value E over rho is 282835.39 Newton. Therefore, by comparing the data, I can conclude that the highest the value E over rho brings the largest sparking loss is not 100% accurate. Okay, the reference I used to explain this example is all from the textbooks. That's all from me today. Thank you.